Hey guys, what's up? I hope your revision and exams are both going well. This is the paper 2A for my predicted paper series for Edexcel. So again, all of these papers are in the Discord. So if you just click on the link in the description, you'll be able to get access to them. If you can't get access to them, feel free to email me. My email is in the description and I'll email you over the zip file of them. Now I just wanted to say a few things beforehand. First of all, I did notice in the last video that there were a few mistakes, and that's kind of embarrassing. This time I've actually gone through every single question, checked it twice, and even sent it to other teachers to make sure that it's all completely fine. The problem is that if I don't have a mark scheme to check from, it can be hard to spot my own mistakes, which is a bit stupid of course, so I gave it to other people. Secondly is I do have versions B and C of these. Now of course I have marks, I am more than happy to do videos of those as well, but that's only if they are actually kind of worth doing, right? So if this video does anywhere near as well as the last one did crazy, so thank you very much to all of you guys who kind of watched it, liked it, commented on it. If this one also does pretty well, then I'll upload paper B and also paper C, but let me know if you want me to actually upload the versions B and C of the paper, okay? But without further ado, let's get into version A of the paper, which is what I believe the paper 2 will look like for Edexcel Maths. Okay, so for the first question, we're going to get that we have a set of all the odd numbers between 1 and 25. A is these 3 numbers, B is these 5 numbers, and C is also these 5 numbers. So complete the Venn diagram. Now I know what you're thinking, but in paper 1 there was a Venn diagram, so does that mean that there can't be one in future? So my advice for how to prepare for paper 2 and 3 is that the stuff that appeared in paper 1, if there was about 10 marks of it, then it won't appear in paper 2 and 3. But things like vectors, standard form, they need to appear every single year. So if they didn't appear in paper 1, they're going to appear in paper 2. So although we had a Venn diagram in paper 1, they can still put a Venn diagram in paper 2 or 3. Okay? So they can definitely still appear. Okay? Anyways, how do I approach Venn diagrams? Well, the first thing is when you get this kind of set theory, and this is also another reason why they might do another Venn diagram, is that this is set notation. I would write out what the universal set is. So all of the odd numbers between 1 and 25. So that is 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, 23, and 25. Okay, and then we start filling it in as shown. So if we look at number 1, there's no 1s anywhere else, so 1 would just be an A, and then I cross it out from the list of A and the universal set. Okay, and this is really important. 11 I see is in all 3, so I'm going to put 11 in the middle overlap, so cross those all out. 7 is just in A again, so cross that out. Then we have 13, so that's just in B, so cross that out and cross that out. Then we have 15, which appears in B and C, so that's in the overlap region there. Boom, boom, boom. Then we have 21, which is in B only. Then we have 17, which is in C only, and 23. So 17 and 23. So the reason why I do this kind of method, and it's not really a rare method, I know a lot of you probably want to do this, but there's 2 reasons. 1, it allows me to check off that I've got everything inside the sets. And 2, writing out the full list and then checking it off means now I can see exactly what goes outside the Venn diagram. And by that I mean outside the circles in the Venn diagram. Because all of these numbers that aren't crossed off need to be written somewhere. And where they're written is outside. So that's 3, 5, 9, 19, and 25. And now, as a final check, we can do this. Now, in an exam, you're going to make mistakes. With Venn diagrams, you get a ton of marks for something that's very easy, right? You're literally just looking at a list and putting them in circles, right? It's not the hardest thing in the world. But for every number that's in the wrong place or missing, you drop a whole mark, okay? So if I didn't write out this list and I missed 2 of the numbers, 2 marks gone. Like, it's stupid. Write out the full list of numbers, okay? And make sure that it makes sense. So, part B, a number is chosen at random from the universal set. Find the probability that the number is a member of B union C. So the way I actually read this is that if it's a U shape, it sounds like B or C. So what's the probability it's in B or C? So that's in either one of these 2 circles. So there's 1, 2, 3, 4, 5, 6 numbers in those 2 circles. And how many numbers in total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 6 out of 13, okay? If you see something like B, N, C, I like to read as B and C, like B and C, you know? So that would be that for that question. Next thing I think that they will kind of test you on, at least at some point in this paper, is truncation. Okay, the reason for this is that error intervals are really common with, oh, they rounded it to 1 decimal place, 2 significant figures, whatever. But truncation is 1 bullet point on your spec, one of about 150 bullet points. Now, what happens when you truncate? Literally, all you're doing is cutting off the number. So let's say if we have a decimal like this. If I truncate it to 1 sig fig, or to 1 digit, that means I literally cut off all of this stuff and I'm just writing the number 6. So essentially when they're saying, what's the error interval for this question, all I'm saying is, what could the digits be after the 5? Well, the smallest it could be is just 5, right? 5.0. Truncate that, it's just 5. Less than equal to n, because it can still equal 5. And now what is the biggest it could possibly be? Well, it would be 5.99999999999 going on forever. So how do you actually write that? Well, you just do it as less than 6, okay? And the reason for that is it's infinitely close to 6, but not quite, okay? But that'll be it for 2 marks. So yeah, be careful of truncation. Go through a few examples. Literally all it means is cutting off the end, right? You're not rounding, you're literally just removing digits. For question 3, we have the time series graph gives information about the number of pairs of t-shirt sold in a clothing shop in the first 6 months of 2018. The sales targets for the first 6 months of 2018 was to sell a mean of 90 shirts per month. Did the shop meet the sales target? Show how you get your answer. So all we need to do is work out a mean given this information, and we need to do a mean of these months here. So how do you do the mean? Well, what you do is you add up all of the values. So in this case, it's going to be the number of shirts sold in each month. We're going to add those all up and divide them by the number of months, okay? And this way you need to be careful, because here there's only 6 months. In questions similar to this in the past, students have just divided by 12 because they thought, oh, months, 12 months in a year. So be careful. So all you're doing is reading it off. So if you have a look, we have in between 100 and 120, that's obviously going to be 110. Okay, so each of these big squares here is 10, which means the little ones are worth 2 each. So that's 110, so let's do 110. Then it'd be 80 for February. And then this is, again, where it gets a bit interesting. So that's 70. So that'd be 72, 74. It's midway between 74 and 76, so it should be 75. Plus 90. Plus, so if that's 90, that'd be 92. 94, that'd be 95. Then you have, so that's 110, that's 102, 104, 105. Okay, add those all up, divide them by the number you have, and you get that. But then you also have to say, so the reason why this is 3 marks, you get 2 marks for actually working out the damn mean, and then you get the last mark for actually saying whether or not they meet the sales target. Again, in previous years, some students just haven't bothered putting an answer, which is kind of worrying. Okay, so just check I put the numbers incorrect. 105, 95, 90, 75, 80, 110 over 6. And it gives us an answer of 92.5 t-shirts per month. And it's fine for it to be a decimal number when it comes to the mean, because again, it's an average. It's not actually saying that they sold 92.5 t-shirts, obviously. So they're meant to sell a mean of 90 and they did 92.5. Well, it's a sales target, which means they should exceed it if anything. So yes, they did. Okay. So again, you get that mark here, the yes, for actually interpreting it, because technically speaking, they didn't meet the they didn't actually get 90 t-shirts. They got more than that. But think of it in the context. It's a sales target. If you get more than the sales, that's just gravy. Okay. So in this case, yes is the answer. Susan and Robert are travelling to work together. They are 36 minutes away from their place of work, according to their average commute time. They are 40 miles away from work. They travel along a road with a speed limit of 50 miles an hour. Susan says, the only way we will get to work on time is to go faster than the speed limit. Is she correct? You must show how you get your answer. There are a few different ways that you can show this. The first way is you can assume a speed of 50 miles an hour and then times it by the distance and then see how many hours it would take you, right? So just do the distance divided by the speed, gives you a time, see if it's more or less than 36 minutes. Or you can work out how fast they would need to go to travel 40 miles in 36 minutes, which is actually the way I would prefer to do it. So speed is equal to distance over time. We need to change our time into hours, so we do 36 divided by 60 to make it into hours, which gives you an answer. So if we simplify that, divide top and bottom by 12, we get 3 over 5, or 0.6. Again, it is a calculator exam, so feel free to use a calculator, obviously. So that'd be 40 over 0.6. And then all you need to do is shove that in your calculator and see what you get. So bring up the calculator, 40 over 0.6, you get 200 over 3, so you get 66.7 miles an hour. Which, if you have a look, is a lot faster than the speed limit of 50. So yes, she is correct in that regard. Again, you can do it and instead assume 50 miles an hour and see how long it would take them, or assume 50 miles an hour and see how far they travel in 36 minutes and show it's less than 40 miles. All of these things are equally kind of acceptable, okay? So for this question we have a diagram showing a floor in the shape of a trapezium. Pavampreet is going to paint the floor. Each 4 litre tin of paint costs £19, basically, £18.99. 1 litre of paint covers an area of 2 square metres. Pavampreet has £160 to spend on paint. Has Pavampreet got enough to buy all the paint he needs? You must show how you get your answer. Okay, so if I was looking at this question, again, if it popped up in my exam, the first thing first is I should probably work out what the area of the floor is. So the area of a trapezium, there's a few different ways to write it. So you can do a plus b over 2h, or you can do a half a plus bh, however you want to do it, by the sub in those numbers. A and b are the 2 parallel sides, so in this case it's 12 plus 14 divided by 2, and then you're going to times that by 9, and so that'd be 13 times 9, which is 117 square meters. Okay, good. Again, getting marks just by doing some stuff. Now it says that every 1 litre of paint covers an area of 2 square meters, and if I look over here, each tin actually has 4 litres in it, right? So I should probably work out how much area each tin actually covers. So each tin covers the number of litres, which is 4, times the 2 square metres it tells me over here. So it's 4 times 2. So each tin covers 8 square metres of area. So then to work out the number of tins of paint I would need, all I need to do, so I'll put hash tins, so number of tins. It's going to be 117 divided by 8. It doesn't go in fully, so I'm going to need to use a calculator, which is the calculator exam, that's fine. 117 divided by 8 gives me an answer of 14.625. Now, if you think about it, we're going to have to round this. Now, if we, again, think about it, 14 tins would not cover the whole thing. No matter, even if this was 14.01, 14 tins wouldn't be enough. So you always round it up when you're talking about buying stuff like this. So we need to buy 15 tins of paint. Pavampreet does. Now he only has £160 to spend on paint. So it's a good idea to work out how much 15 tins would cost. So the cost here is going to be 15 times 18.99. And that will be, or hopefully will be, our final answer. So again, 15 times 18.99. £284.85, which is more than his budget. So no. And if you notice, we've basically done 4 steps here. So 1, 2, 3, 4, and then 5 for the actual final answer. Okay. So it's probably as efficient as you can be with it. You could, some students have asked me, by the way, can you just write them like no? Well, obviously not. You need to write something. But if you wrote cost equals this, so no, you could technically get all 5 marks. But if this cost is slightly wrong, just be aware you might lose some marks for that. Here are the first 5 terms of an arithmetic sequence, so 8, 13, 18, 23, and 28. Write an expression in terms of n for the nth term of this sequence. Now, I've actually shown you guys before a couple different ways to do this, okay? So I'm going to put a line down the middle. And this is technically an A-level formula, but you can use A plus m minus 1 d and actually leave it in that form. And A and D are just the first number, so a in this case would be 8 because it's the first number in the sequence. And what is the difference? Well, to work out the difference, all you need to do is, so 8 to 13, that's plus 5, plus 5, plus 5, plus 5. And then all you'd have is 5. Okay? Then if you want, you can expand it, so you get 8 plus 5n minus 5, in case they ask you to give it in its simplest form. So that would be 5n plus 3, right? Because 8 minus 5. That's one way you can do it. And again, if they don't specify a like simplest form or anything, you could leave it like this. However, this is the most simple form. However, some people are a bit confused, so let me go through a second method which might be more appropriate for you. Another method of doing that is, once again, you work out what the common difference is, right? So here it's plus 5, plus 5, plus 5, right? And all you do is you write that number in front of n. Okay, so 5n. If the difference was minus 3, you'd put minus 3n. If the difference was 10, you put 10n, and so on. And then what you do is you go 1 before the first term. To do that, you'd subtract 5, which gives you 3. And then all you do is you put plus 3. If that number was minus 3, you'd put minus 3. If it was plus 10, you'd put 10, etc. Okay, so that's probably the fastest way you can do it. So again, you find the difference and just put that in front of n, whether it's positive or negative, doesn't matter. Then you go 1 before the first term. So if you're adding 5 each time, you'd subtract 5. If you're timesing by 2, divide by 2, whatever. And you just put that number on the end. And that's probably the quickest way to do it. Okay. Then tells us that the nth term of a different arithmetic sequence is 11n minus 4, is 128th term of this sequence. Sure, you get your answer. So the methodology here is, all you do is you write the nth term and you equate it to the number that they're talking about here. Okay. Now, all we're doing is solving for n. If n is a whole number, an integer, right, that's positive as well, so it can't be negative 2 or something, then it is a term in the sequence. Because remember, n just tells you what position you are in the sequence. First, second, third, fourth. You can't have 1.5, right? So it needs to be a whole number. So let's add 4 to both sides. We get 11n equals 132. And then n is equal to 132 over 11, which is 11. 12 even. It's 12. So it is a term. And that's as simple as, okay, because we've got an integer number. The table below shows information about some of Saturn's moons. And then it says, write down the name of the moon with the greatest mass. So all you're looking for here is the one with the biggest power. If there are two with the same power, like these two, then all you do is you compare the numbers in front. So between Rhea and Lepettus, this one, Rhea, is actually bigger because 2.3 is bigger than 1.8, even though they have the same power. Now, Titan is actually the greatest mass because it has times 10 to the power 23. Nice and simple, hopefully, assuming you know how to read standard form numbers. Then it says, find the difference between the diameter of Titan and Enceladus. So all you need to do there is you're subtracting, right? So you're doing 5.149, so let's just use a calculator. It's a calculator exam, nice and easy. So Enceladus is, Titan and Enceladus, so we do 5.149. I'd also recommend, as I'm doing, to put it in brackets, because otherwise your calculator might do weird stuff in terms of adding and subtracting before each other, right? Because technically in BIDMAS you have multiplication then subtraction, but sometimes it can get a bit wonky when you use a calculator. So then it should be 5.04. Again, not always, so it might work in this case, but just to be safe, always put standard form in brackets if you value your life and your marks. Okay, so just subtracting them, we get that. We don't need to give it in terms of standard form because it hasn't actually stated. But just in case, let's say it did state put it in standard form, that would be for a second mark, hypothetically. All you'd do is you'd write the first non-zero number, so 4, then you put a decimal point in every other number that isn't a 0. So 6, 4, 5. Then you put times 10, and you do it to the power of how many digits are after 4. So it's not just the number of zeros. Not always, right? So in this case, how many digits are after number 4? 1, 2, 3, 4, 5, 6. That'll be it in standard form, okay? So it's not just count the zeros. I have had multiple students just write, oh, times 10 to the power 3. Okay, so just wanted to go through that whilst we're kind of talking about it, okay? Darren says that Titan is over 1,000 times heavier than Mimas. Is he right? Shall you get your answer? This is quite simple. All we need to do is take the mass of Titan and divide it by the mass of Mimas. So Titan is 1.35 times 10 to the 23, I think it was. And I know that Mimas was 10 to the 19, I think I saw. Yes, 1.35 times 10 to the 23 and 4 times 10 to the 19. Divide those two, and then we can just see if the number is bigger than 1,000. This will give me how many times bigger Titan is than Mimas. Okay? So 4 times 10 to the power of 19. And we get that. So it's actually 3,375 times bigger. So in short, he's right. Actually, I shouldn't say bigger, I should say heavier. So yes, he is indeed right for that question. The diagram shows the position of 3 points A, B and C on a map. The bearing of B from A is 080 degrees. ABC is 35 degrees as shown. AB is equal to CB. Work out the bearing of C from A. So first of all, the bearing of B from A. So the second letter is actually where you're starting from. So it's of B from A. So you go clockwise from north, from A, down to B. So that's that angle there is 80 degrees. Okay? Then it says we need to work out the bearing of C from A. So to do that, we will actually need the full angle from here to here. Because again, all you do is you go clockwise, starting from A, north line, all the way round to C. So to do that, we actually need to work out this little green line angle here, add them together, job done. Nice and easy. Now, the other piece of information they give us is that AB and CB are equal. So this is actually, although it may not look like it, an isosceles triangle. So to work out the green section, all I'm going to do is do 180 minus 35 and then divide by 2. Because 180 minus 35 will give me both of these angles added together. And because it's isosceles, they're both the same. So then that would give me 180 minus 35. That would give me 145. So it should be 72.5 degrees. Okay. Which means the bearing is equal to 80 plus 72.5, which is 152.5 degrees. Now, if you remember rightly, bearings must be given as a 3-digit number, which means if it's 2 digits, you add a 0 in front, but if it's a decimal, you always round it. So just 153 degrees is your final answer for that question. Box plot shows the weight of some male pandas at a zoo. It says work out the interquartile range for the weights of the male pandas. So interquartile range just means you do the upper quartile minus the lower quartile. Okay, nice and easy, I hope. So the way we do that, we can read it off the box plot because these three parts of the box are the quartiles. This is the lower quartile, this is the upper quartile, and this is the median or middle quartile. So the upper quartile is 90, lower quartile is 70, so the interquartile range is 20 kilograms. Not too bad, right? Part B, it says, then we have information about the distributions of female pandas at the same zoo. On the grid, draw a box plot for the information. So what do we plot on a box plot? Well, this is the lowest value, this is the highest value, and again, lower quartile, median, and upper quartile, okay? So all we're going to do is put the smallest value, 45. So that'll be midway between here. So 1, 2, 3, 4. Okay, so it goes up in 5s between 40 and 50, which means that each individual box is 2. So 2, 4. So there, let's put it like this, for instance. 65 is the lower quartile, so let's put that there. And again, it'll be 2, 4, so it'll be middle through there. Cool. Then we have median of 70. That should be nice and easy to plot. That 80 is the upper quartile, and then 95 is the largest value. So 90, 92, 94, 95 would be midway through there. I personally choose to make the like whisker parts of the box bigger than the other parts, just for aesthetic reasons. You don't have to do it. There's no need to do it. And that would be the box plot. Cool, right? Now, Bob says the box plot shows the male pandas are heavier than the female pandas. Is he correct? Give a reason. So when you look at these box plots, you can kind of look and you can see, okay, what does it tell me? Well, from looking at this, if this is the female pandas, they do look to be skewed towards lower weights. However, that's not good enough. When we compare box plots, we look at two things. One, we look at spread, which is the interquartile range, right? So how spread out is the data, right? How consistent is it? If we're looking for the actual value, though, we look at the average, which is the median. So all I would say here is that he is right because the median of the female pandas is lower than the median of the male pandas. So yes, the median for male pandas, or of the male pandas, is greater than the median, or just than median, of female pandas. Okay, simple as, quite a short question really, but the box plots don't come up that frequently, so they're probably banking on people not really knowing what to do with them. It's 5 marks, which I think is actually pretty generous. Population of a group of rabbits in the wild increased by 7.3% in 2016. So at the beginning of 2017, the population of the rabbits was 12,500. Craig assumes that the population will continue to increase at a constant rate of 7.3% each year. Use this assumption to estimate the population of the city at the beginning of 2020. Give your answer correct to 3 significant figures. So this question is applying iteration to real life situations, okay? So you are expected in your GCSEs to be able to translate situations into maths, whether it be linear, quadratic, or things like iteration. So as we can see, the population of rabbits in this city is increasing by 7.3% every year. Well, at least we assume so. So what does that mean? Well, that means it's increasing by 100 plus 7.3. It's increasing by 107.3% every year. Okay? So what we can do is we can start off with 12,500 equals, then we can do answer times 107.3%. Okay? And we can just keep doing that until we get to our number. So this is at 2017. So 2018 would be this number. 2019 would be this number. And 2020 would be this number. And if you notice, we do get a decimal. And again, this is the whole part of them wanting to test if you know how maths is used in real life. So the first test was to make sure you could understand the equation, that you had to use iteration. The second test is that if you put a decimal, well, that's no bueno, right? You can't have 0.2 of a rabbit. But either way, it says give your answer to correct the 3 sig fig. So all we have to do is do 15,400 for 3 marks. Pretty generous. It then says use his assumption to work out the year in which the population of rabbits will reach 23,500. Well, that's 2020, right? So let's keep going until we get to 23,500. So 2020, 2021, 22, 23, 24, 25, 26. So 2026. That's exactly how I'll do it. So you might wonder why there's so many marks for this. Well, because believe it or not, this is the method that you can use. Okay? And you'll always get it right. It's always full marks. It's all fine. But you get marks for kind of interpreting the situation you've been put in. And if you look at a lot of iteration questions, they give you a lot of marks for just doing this. It then says, if Craig's assumption about the rate of increase is too high, how will it affect your answer to B part I? Well, let's think about this. If it's too high, then that means the actual percentage increase is lower, which means I'm timesing by a smaller number, which means it would take more years to reach 23,500. So 2026 is too soon. Okay? Or you can say something like, it will reach 23,500 at a later date or a later year. Okay? So you get 2 marks for this question, 1 mark for this question. Hopefully nice and easy. 6 marks. I don't think it's too bad, but trust your gut and actually interpret the situation that you're looking at. A football tournament consists of 24 teams. Each team must play each other only once. How many matches will there be in this tournament? This question is really, really interesting. This topic or subtopic is called combinations, sometimes called combinations and permutations, okay? Sometimes. And it's 3 marks, so it's not insignificant. So, how exactly would I approach this? Well, First of all, it consists of 24 teams, right? Cool. I would scale this down a bit. Let's say we had 5 teams, right? Team A, B, C, D, E. For each team to play each other, A will have to play B, C, D, and E. B would play A, C, D, and E. C would play A, B, D, and E, and so on, right? So each team can play 4 other teams. So in this case, if there's 24 teams, there are 24 teams, and they can play 23 other teams, right? Because a team can't play itself. But, and this is a big but, each team must play each other only once. So, you know when I said before, A can play B, C, D, and E, and B can play A, C, D, and E? Well, let's actually write out these combinations, right? We have AB, AC, AD, AE. Then we have BA, BC, BD, BE. Then we have, I'm not going to do all of them, don't worry, so, yeah. If you have a look, B playing A and A playing B is the same thing. B playing C and C playing and C playing B is the same thing as well, right? So you notice that we actually have these kind of double matches, right? So how do I get rid of them? Well, it's quite simple. All you have to do is divide by 2. And that will give you the number of different teams, the number of unique matches that you can play. Okay? So 24 times 3 is the total number of matches if each team plays each other. But if they only play each other once, it's 276 matches. Okay? So be really careful with that. Again, if you just did 24 times 23, you would get 2 marks. You get the third mark for actually dividing by 2. Okay? Website has 2-factor identification, email and phone verification. Probability that someone will have to do email is 0.6. If they do the email, probability of them not having to do phone is 0.8. If they do not do email, the probability of them having to do phone is 0.9. Complete the probability tree diagram for this information. Okay, so it says the probability that someone has to do email is 0.6, so that'd be 0.6 here. And because the branches have to add up to 1, the probability that they don't have to do it is 0.4. Okay, so I'm going to tick that off because we've used it. If they do the email verification, so we're looking at this top set of branches here, probability of them not having to do phone verification is 0.8. So the probability of them having to do it is 0.2. Because again, it has to add up to 1. If they do not do the email verification, the probability of them having to do the phone is 0.9. So that'd be 0.1. Cool, right? But again, do it line by line and tick things off, okay, to make it super, super clear. Sammy just logged onto the website and she only had to do one form of verification. Is it more likely she had to do the phone verification or the email verification? Show how you get to the answer. Well, if she only did the email verification, right? Again, so that would be, if she only did the email verification, that would be she did the email and then didn't do the phone verification. So what's the probability of that? Well, that's 0.6 for the email verification, and then she didn't do the phone verification, so times by 0.8. Okay? That would be the first kind of method. Now, if she just did the phone verification, then she would have to not do the email verification and then do the phone. So probability of not doing the email is 0.4. And then doing the phone after that would be 0.9. 0.36. So which is it more likely she have done, the phone or the email? Well, it's more likely she did this one, which is the email verification. That's it. Not too bad, but I can easily see some people getting mixed up. One of the common mistakes in questions like these is that when it says what's more likely, phone or email, they go, well, email is 0.6, phone is 0.9. Or worse, 0.6 and phone is 0.9 plus 0.2, which is 1.1. You have to fill out the full thing, right? So just make sure that that makes sense. John invests £5,000 into a savings account for 3 years. The account pays compound interest at an annual rate of 1.5% and then X% for the second and third year. There's a total amount of £5,436.47 in the savings account at the end of 3 years. So here's how I do that. The equation for working out compound interest is you take the original amount, you times it by the percentage increase, and if there's two different percentage increases like we have here, we can just chain them on nice and easily. So 1.5% is a 101.5% increase, right? So we're going to times that by 101.5%. To the power of the number of years, that's just 1. And then there's X% squared, because it's for 2 years, right? So you can just chain them on like that. It's nice and easy. And that should give me an answer of 5436.47. So what I'm going to do is I'm going to divide both sides by 36.47. 5,000.5%. Okay? And that should give me, so all we need to do is actually do this division. 5436.47 over 5123 times 101.5. Wait, is it 101.5? Yeah, it's 1.5%. That's good. Oh, paranoid for a second there. Which is 1.07 blah 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 blah. Right? So then x is going to equal the square root of that. 1.035. So if I times that by 100, I'll get the percentage. So that would be 103.5%. Right? Logically. So the actual interest rate isn't 103.5%. It's just the 3.5%. Because remember how we worked out the percentage increase here? We added 100 to this number. So now we need to take 100 back off. So that'd be 3.5% interest. Okay? Because again, we added 100 to the original number because that's how we do the percentage increase. So this is telling me the percentage increase, not the interest rate. The interest rate is this number minus 100. Then it says John's shopping has increased by 15% to £86.25. Work out the cost of John's shopping before the increase. The way I like to do this is if it's increased by 15%, it's currently at 115% of its original value. So a few different ways to do this. 115% equals 86.25. So what you can do is, I don't know why I put the decimal point in the wrong place. What you can do is divide both sides by 115 and then times by 100 to get to the original, right? Again, there are other ways to do this that might be quicker for you or just different. You can use whatever method you like as long as you get the right answer. With percentages, you know, there's a load of different methods for it. 25 divided by 115 gives me 3/4, so 1% is equal to 0.75. So then to get to 100%, because remember 100% is going to be its original value, we're going to times both sides by 100. So 100%, his original cost of his shopping is £75. Okay. There's a few different ways of doing that, okay? For this question, it's one of those kind of calculator use questions. It's not that bad, but they also mix it in by putting a definition question, prime number. So all you want to do is you want to work this out on your calculator. So let's do that. You've got 4 power 5 minus 48. Gives me 976. And then they rely on you knowing what a prime number is. A prime number is a number that can't be divided by anything except itself and 1. This is an even number. So the only even prime number is 2. So this is not prime. Not prime because the only even prime is, actually no, it's not, is 2. The other way you could do it is just show that you can divide it by another number, right? So you could also do divide 2 equals and then whatever that equals, right? I think that'd be what, 470 something? Anyways, no, it's not, 488 it should be. Okay? In which case that shows that it's not prime because it can be divided by something other than itself and 1. We have some more of these recurring decimals to fractions questions. The way you do this is you just write x is equal to and then you write your original value. And then the goal is to times x by something to make the actual decimal bit, the part after the decimal, the exact same. I know that sounds a bit weird, but you know, it's just the way it is. And the way you do that is all you do is you times it by 10, 100, 1,000, whatever. And how do you decide? Well, you decide by how many recurring decimals you have. Because we have 2 recurring decimals, we're going to times it by 100, because the number of zeros should equal the number of recurring decimals. So if it was like 398 recurring, you times by 1,000. If it was just 3 recurring, you times it by 10. If it was 3987 recurring, you times it by 10,000. Okay? So we're going to do 100x, and if you notice, you're going to get 39, and then it will still have the exact same recurring decimal. Then you're going to subtract these from each other. So 100x minus x equals, so that'd be 39.39 recurring minus 0.39 recurring, so you're just left with 39, right? Again, you can use your calculator for this. So 99 x equals 39, x equals 39 over 99, which if you divide top and bottom by 3, you get 13 over 33. They're usually worth a decent number of marks, so in this case it's worth 3 marks, and they're not that bad once you've got some practice with them. I would thoroughly recommend practicing these, okay? Here's a graph of y equals f of x. So it's an upside down sad face, so it's a quadratic. Write down the coordinates of the turning point. The turning point is the point where it turns. I know, shocking, right? So in this case, it's this kind of peak that we have. If it's a happy face, it's the trough, right? The lowest point that it ever gets to. And this is the highest point it ever gets to. And the coordinates there are just -1 and 1. Nice and easy, not too bad. When it says write down the roots, so f of x equals 0, roots just mean solutions, right? But the best way to think of it is it's always where it crosses the x-axis, okay? If it equals 0. So if it's f of x equals 0, or the roots of the equation equals 0, whatever it is, it's the solution. So it's wherever it crosses 0, which in this case is -2 and 0. Then it says write down the value of f of 1. F of 1, remember, if it's f of x and now it's become 1, that means they've just subbed in x equals 1. So we look on this graph, x equals 1, where does that touch the curve? At -3, okay? So f of 1 should just be -3, because that is on the graph where x is equal to 1. Here's a layout that some of you are probably familiar with, especially if you watched my circle theorems video, right? Sick plug. A and C are points on the circumference of a circle centre O. BC is a tangent to the circle. OBC is 36. Work out the size of the angle marked X. So first of all, you have to give a reason for each stage you're working out. Well, first of all, OCB equals 90 degrees. Because tangents meet radius at 90 degrees. Now it should be noted, this question is 4 marks, so you only need to give 2 reasons. So that's our first reason. You don't need a reason for every single step, although I would recommend it. Now you can work out that COB. So for this reason, I'm actually going to write a reason for every single step, even though you don't technically have to. You normally only get marks for 2 reasons. Right, so all we need to do is do 180 minus the 90 minus 36. So again, let's be lazy. 180 minus 90 minus 36 gives me 54 degrees. So this angle here is 54. The reason for that is angles in a triangle. Add to 180 degrees. Okay, nice and easy so far. Now this angle here is just going to be 180 minus 54, so 126 degrees. Okay, reason for that, angles on a straight line add up to 180. Now here's where it gets interesting. These two lines here are actually the same length. But how do you know that? Well, look, those lines are from the center of a circle to its circumference, which means they are, by definition, the radii of the circle, because they're from the center to the circumference. That's by definition the radius, okay? So if both of these are the same length, and that means that's also x, then that means angle x is just 180 minus 126 to work out both these angles added together, and then divide by 2. And that's it. Okay, so that's 54 divided by 2. In other words, it's 27 degrees. Okay? And again, reasons there, because base angles of an isosceles triangle are the same size. Here's a right angle triangle, and it has two measurements, x minus 4 and x plus 1. All measurements are in centimetres, the area is 5 centimetres squared. Find the perimeter of the triangle. So how do we find perimeters? Well, to find the perimeter, what we need to do is add up the three different sides. The problem is that it's in algebra, and we also don't have the third side. So let's take care of the algebra thing first. What else do they tell me that's useful? Well, the area of the triangle is 5 centimetres squared. Well, how do I work out the area of a triangle? Well, I do half base times height, which is x plus 1, x minus 4. And that should give me 5. Now, because I don't like fractions, I'm going to times the whole thing through by 2, which gives me x plus 1, x minus 4 equals 10. Okay? Now I'm going to expand the brackets. X times x is x squared. X times minus 4 is minus 4x, and then we have the plus x as well, so we minus 3x. Minus 4 equals 10. Subtract 10 from both sides, we get x squared minus 3x minus 14 equals 0. So now we can either factorize or do completing the square or the quadratic formula. So because I haven't really shown the quadratic formula in these kind of walkthroughs before, I'm going to show the quadratic formula. It's just minus b, so minus of minus 3, plus minus the square root of b squared, so minus 3 squared, plus minus 4ac, so b squared minus 4ac, where a and c are just the numbers in front of x squared and the number at the end respectively, all over 2 times a. That gives me my first value, so it looks like we couldn't have factorized anyway. That's 5.53. And we need to do the minus version in order to get the other value. And we get minus 2.53. So how do we know which one to choose? Well, if we look at what x is, it's the length of a side, right? So it can't be negative. So we're going to put a line through that. This is the value we're going to choose. Perfect. Now to work out the perimeter, what we're going to do is we're just going to work out the lengths of these sides. So 5.53 minus 4, so that's actually going to be 1.53. 5.53 plus 1 is going to be 6.53 centimeters. Okay. Then we need to work out this side, so we're going to use good old-fashioned Pythagoras. So that's going to be square root 1.53 squared plus 6.53 squared, all square rooted. So let's do that. Square root 6.71, let's call it. Okay. So now what's the perimeter? Well, all we need to do is add up these three sides. So the perimeter is just going to equal 6.71 plus 6.53 plus 1.53. That gives me 6.71 plus 6.53 plus 1.53. Gives me an answer of 14.77, but three significant figures, that's going to be 14.8 centimeters. Not too shabby, I think. Has a few steps to it, but it is a 6 marker, so that takes a bit of getting used to. You have to solve quadratics, you have to do all this fun stuff. Solving quadratics alone is 3 or 4 marks, then Pythagoras and doing this. But again, if you break down the question into individual chunks, you can A, get method marks. Keep in mind the answer only gives me 1 of the 6 marks, right? If you think about it. Getting the method is actually what matters in this case, although if you did just write the answer, you would get 4 marks. And just breaking it down and kind of writing down what you need and then seeing if there's a way to get what you need. There always is, right? Because questions have to be possible. Here we have some column vectors. This stuff hasn't come up that much. So again, there's a good chance they might come up this year. So the vector C, we have to do 2 things. We have to multiply scalars and vectors, and we have to subtract vectors. Let's see what happens. Well, we're going to have 2, then we're going to still have the brackets here. And I'll show you exactly how you times. It's actually very, very easy. To times vectors by scalars, you literally times every number inside the bracket. So 2 times 3 gives me 6. 2 times 2 gives me 4. Then the minus 4, you have 2 options, right? So what we could do is leave it as minus and then do 4 times 5 and 4 times minus 6, which is what I'm going to do. So 4 times 5 is 20, 4 times minus 6 is minus 24. The other thing you could have done is actually times by minus 4, but then you have to remember to swap the signs. It gets a bit messy, so just leave it as is. Then to subtract vectors or to add, you literally just subtract the top or add the top and do the same at the bottom. So 6 minus 20, that gives me minus 14. 4 minus minus 24, so that's 4 plus 24, that's 28. That's it. Okay, so testing 2 parts of the spec right there. Lastly, we have simultaneous equations. So what's the method here? Well, the first thing you want to do is you want to make either the x's or the y's the same. In this case, both of them are not only viable, but they're both pretty much as easy as each other. So you have a choice. You can either times this equation by 4 to make the x's the same, or times the top equation by 3 to make the y's the same, okay? I'm going to choose to do the first option, so times this one by 4. And I'm going to write it in the exact same orientation. So 4x plus y equals 25. Then the second equation now becomes 4x minus 12y equals 16 times 4, which is 64. And then what we're going to do is, because these numbers are the same, because they're the same sign, we're going to subtract. So remember the 3 S's. Same sign subtract, different sign add. Same sign subtract, okay? So whether they're both positive or both negative, you subtract. 4x minus 4x is 0. Y minus minus y would give me 13y. And then you know what? We do have a calculator. Let's get lazy. Let's do this. 25 minus 64 gives me minus 39. So 13y is equal to minus 39. Y is equal to minus 3, because all you do is divide both sides by 13. Now, to work out x, all you have to do is sub it into one of the 2 equations, and you can choose whichever one you want to do. In fact, we have 3 equations, right? We have these 2 and also this one. I'm going to sub it into the very top one just because I want to. So 4x, then it says plus y, but y is minus 3, so let's just say minus 3 equals 25. Add 3 to both sides, 4x is equal to 28. Divide both sides by 4, x is equal to 7. Those are my 2 answers. And that is for 4 marks for the final question. So I hope you found that useful. Hopefully you find it kind of interesting. I will upload the mark schemes for the other 2 papers as well, assuming this video does relatively well, just because I want to see if it's actually worthwhile. Otherwise, I will just kind of do written mark schemes instead. But other than that, thank you very much for watching. I hope your exams are going well. I hope your revision goes well.